Good day everyone. Today, our group will walk you through mineral and rock identification. The following characteristics were used for the identification. For minerals, we had crystal form, luster, color, streak, hardness, cleavage, fracture, and specific gravity. For rocks, we had color and texture. For mineral identification,
Sapphire is one of the gem varieties of the mineral called corundum. To discuss sapphire's physical properties, let us first start with its crystal form. It usually occurs as hexagonally shaped prismatic and tabular crystals and as bipyramidal hexagons that are wider in the center and taper thinly on the ends, usually elongated and striated crosswise, and sometimes occur in thin plates and are commonly smooth or rounded on the edges due to alluvial action.
Moving on to another property called luster, sapphire can be vitreous to adamantine. As for its color, it ranges from cool shades of colors such as white, blue, green, and purple, in contrast with its other corundum variety called ruby.
As for sapphire streak, it is usually the color white, which means that it is harder than the streak plate itself. According to the Mohs scale, sapphire or corundum has a hardness of 9. Corundum is a very hard, tough, and stable mineral. For all practical purposes, it is the hardest mineral after diamond, making it the second hardest mineral.
Sapphire has no cleavage. However, it exhibits basal parting and rhombohedral properties. Rhombohedral pertains to the six-sided polyhedron with each side shaped as a rhombus, which have different angles with each other. This mineral has an uneven fracture as well, which leaves a rough or irregular surface on it. Meanwhile, sapphire has a specific gravity ranging from 3.9 to 4.1. This kind of gravity makes it possible for sapphire to sink in all commonly used heavy liquids.
for rock 1 identification,
Moving on to rocks, we could see that this rock exhibits small white and black grains. As we look closely, small vesicles are also present and the white grains seem to be enclosed inside some vesicles. This means that the rock has undergone rapid surface cooling. Furthermore, the rock exhibits dark gray color and could possibly contain plagioclase, which is the white grains, and amphibole presented by the black grains. Based on all these observations, we could identify the rock as a mafic vesicular amygdaloidal basalt with genetic classification as extrusive igneous rock.
for rock 2 identification, moving to our next rock, here we can feel it's relatively more fine-grained. On this side, we can see evidences that it has been split into thin layers parallel to the bedding plane, thus exhibiting fissility. Discrete fragments of pre-existing rocks can also be seen here. As observed as well, the particles are almost too small to be seen by the naked eye, indicating that it may be composed of mud particles which may have been silt and/or clay. Additionally, it is mostly gray in color. However, we can observe reddish pigments right here, which may have been indicative of presence of ferric oxide. With these descriptions, this rock can be classified as a clastic detrital sedimentary rock, specifically a shale.